Awesome. Yeah, so I'm Sam Kottler. I'm going to be talking about something that happened to Rubygems.org and kind of how we're moving forward and what happened, and hopefully it'll be interesting. That's where I live on Twitter, at Sam Kottler. It's pretty straightforward. But I'm sure a lot of you are kind of familiar, at least, with what happened. And essentially what happened is we had kind of a security incident, and I wasn't involved with Rubygems until this happened. So it's kind of interesting how I got involved, and I'm going to talk about that a little bit, and then also talk about kind of how we're driving Rubygems forward and kind of the future of Rubygems and how you can help, which is a big part of this talk. So for those of you unfamiliar with Rubygems, which I assume is a fairly small number of people, Rubygems is where all the gems live. So when you run gem install, most of the time you're talking out to Rubygems. And when you're a gem author, you upload to Rubygems. So you say, here's a new Rails release. I want to upload the new Rails gem. And as an end user, you then gem install Rails, and you get the latest version. Or increasingly, you run bundler and run bundle install, and then you get all of the gems that you need for your project. And Rubygems, I'll talk a little bit more about the architecture, but Rubygems is basically, for the gem installation side, a giant 302 engine. So Nginx, which sits in front of the actual web application, just redirects to an S3 bucket. So when you run gem install, you're actually installing off of S3. And so you get a 302 from Nginx. And so the way that the actual incident started is Hacker News, yay. So this person, well, actually, Nick wrote this. This person, he said, I downloaded the exploit gem and found that they used the psych hack, which is a YAML hack, not surprisingly, to post some config from the application to pasty. Luckily, none of the API's keys were there because it still runs on Heroku and uses environmental variables, which provides, I guess, some level of protection. So this is basically what I think of people who post shit on Hacker News, especially exploits. Like, why did you do this? Not cool. Don't do that, ever. This is the actual exploit, which essentially just grabs the database config, the New Relic config, the Librado config, and rubygems.yaml, which has Amazon S3 configuration and some other stuff, and post it to pasty. And so the internet kind of exploded, and Twitter kind of exploded, and New Relic posted this, and they were like, we're not sure what's happening, no one's telling us, something happened, it might be serious, who knows. And then they said, you can verify our gems. And there were lots of articles like this. And this is because people didn't kind of responsibly disclose stuff. So now kind of to the heart of the talk, which is how we rebuilt the Rubygems infrastructure in a pretty short period of time. And one of the things that we kind of decided right away was that we were going to rebuild. It wasn't really that much of a choice. So a bunch of people, after this initially happened and people saw what was going on Twitter and other places, kind of hopped onto IRC and were just waiting around and trying to figure out what to do. So like I was yelling like, hey, I have a comped Rackspace account. Who wants instances to verify gems? All this different stuff that was going on. And a big part of what people were doing was waiting around, and there was a conversation about whether the infrastructure, which was on Rackspace before, should get rebuilt somewhere else or rebuilt on Rackspace. And one of the things about security issues, and I've dealt with other open source security issues with the Fedora project and other things, is you kind of have to rebuild because you don't know what happened, and really kind of skilled hackers can replace binaries that can prevent you from knowing what happened. So you have to kind of start over. And a big part of starting over for us was figuring out what did what. So like, I tweeted this, which was kind of, that was an asshole move, but it happens. No one knows how rubygems.org works. Oh my God, the world is ending. How do we fix this? And so part of the kind of initial rebuild experience was just, we decided that it made a lot of sense to build something publicly that people could then reproduce. And one of the awesome outcomes of this, which I'll talk a little bit more about, is we now have a really, really reproducible rubygems.org. So if you want to stand up your own version of rubygems.org, you can do that. So you know, if I'm 37 Signals or if I'm Red Hat, which is where I work, I can say I want to stand up, you know, a version of Rubygems, and we'll put our own gems there. And that's a really cool thing because now we have Chef. So again, just a takeaway was that it made a lot more sense to rebuild something publicly than it did to continue kind of the lack of knowledge intake. And so there are also issues with building things publicly, like you don't put passwords into Chef when it's going to be public. And you probably shouldn't do that anyways, but you really don't do it when it's going to be public, because then people don't even need to use YAML hacks against you. So we decided that it was going to be public. And the stack is pretty vanilla, which is a great thing. It's Rails, Nginx, Thin, Postgres, Redis, and Memcached, which is a pretty standard Rails stack, which made it really easy because we started this repository. It's still open. You can watch it. You can contribute to it, please. And we decided that we were going to put everything in there. And so we started with this guy, Philip's Chef config. And this is what it looked like, which is what the current Rubygems architecture looks like. So essentially the way rubygems.org works now is the front end, when you go to rubygems.org, it's a VIP. It's an EIP in AWS terms, that then has an Nginx load balancer in front of it, that if you're trying to install a gem, you go to an S3 bucket, and if you're trying to hit the application, like gem upload, for example, hits the application, then we have a Redis Memcached and Postgres behind a Rails stack. So it's pretty simple to actually get started with, and it's really easy to stand up. Right now it runs on 3 AWS instances. So all of Rubygems runs on 3 AWS instances, which is actually a problem, and I'll talk about that too. So we kind of started, and we imported Philip's initial thing from his company. So he took his company's ops repo, and we just kind of uploaded it without certs in it, which we thought there were certs in it, and we thought his company was in trouble, and he was in trouble, but there weren't. So we kind of started fresh, and the cool thing here was we had a completely new AWS account, we had a completely new repo, and we were using Chef and Knife to upload. Anyways, so we started rebuilding, and a big part of the rebuilding process was being able to kind of start fresh, and since we had all this old infrastructure, we had to migrate. Luckily, the actual installation is pretty straightforward, so it's like some S3 keys, and a Postgres database, which is only about 5 or it's probably 7 gigs now. And so as we started migrating, one of the things that we noticed was that like we kind of had to deal with AWS constraints all the way. And so one of the early decisions that we made was that it didn't, oh, awesome, cool, internet. So one of the early decisions that we made was that it made a lot more sense to kind of build things in an AWS agnostic way, and I'll talk about how that's useful for us now. So we were there. And it was funny because like people whose names you know started helping. So like the author of Vagrant, Mitchell Hashimoto, like wrote our Vagrant file because he was like, you should use Vagrant and everyone can do local dev. He should fix it because it's broken right now. So I might ask him to do that. But essentially, a big part of what we were doing was kind of fixing a problem that had been around for a really long time. And everyone knew, I mean, like, Evan and Nick like knew that it wasn't in the best shape and that it was kind of time to start thinking about this. And so we just got to do it in a really short time frame. So you can now run this, which is, give me a Postgres server that looks like the Postgres server that we use on rubygems.org. You can also install it all on one VM. So like if you have if you have a free gig of RAM on your laptop, like you can stand up Rubygems and hack on it and help improve the infrastructure, which is a massive improvement. We were on CentOS 5 before, and that's old, and old things are bad, usually. So we have this repo. It's very open. If you want to contribute to it, we love pull requests. And there's actually a blog post I need to publish about kind of how to, and I'm planning on doing that this afternoon, but there's a blog post about how to actually contribute infrastructure changes, because one of the things is people who are trying to contribute actually don't have access to see what's going on the servers most of the time. And so that makes it really challenging to actually have people get involved because they don't know what it looks like out in the wild. And so I kind of need to explain how that works. And one of the things that we've been working on recently is getting real monitoring in place. So in our case, we're just using Datadog, which is a hosted service. But you know, we basically had no monitoring before. It's still not great, but it's better. And this lets us detect problems early, just like you would with real infrastructure. So we're basically treating Rubygems.org like a thing, the way it should be treated now, which is kind of have it monitored, have people who kind of get alerted on it. One of the other things is we're considering setting up kind of an on-call schedule. So if you are interested in getting woken up in the middle of the night because you're a masochist or something, reach out to me, I guess. So I kind of want the focus of this talk to veer a little bit, which we rebuilt the infrastructure in about 60 hours. So it was January 30th when we first started rebuilding, and we relaunched on the Saturday after that. So I actually was like in Vail, so I was offline when this happened. But Friday night to Saturday morning, we were just testing, so I left Friday night. But basically, a lot of people stayed up for 48 hours and some longer to help test the relaunch. And this was a pretty mammoth effort just because it's a pretty high-profile site. And one of the things that we kind of need to do going forward is to encourage contribution. So if any of you are interested in helping with any of these projects, there are conversations that I can kind of introduce you, or Nick, or anyone who's involved. You can find stuff on mailing lists and other places. But there's a lot of work left to do on Rubygems. And so that's the point of this talk is we did this thing that helped a lot, and it's kind of improved the situation a lot, but it's still not in awesome shape. So we're not HA right now. As I said, we have 3 instances. So we have a Postgres instance that also runs Redis, and then we have memcached on an app machine and a load balancer, and that's it. So if that load balancer goes down, no one can gem install. That's bad, because AWS just like goes away randomly. If you've ever used it, it goes away all the time. And so there are all these things that we need to do. So one of them is consider kind of using diverse providers. So we can use Rackspace and AWS and multi-region AWS, and kind of consider how to split out services. And that introduces a lot of concerns. So one of them is like, how do we deal with DNS across lots of different systems where we have to load balance traffic between them? Do we use kind of geo availability? How do we do that? But since we have no reliance on AWS's specific services, like we don't use ELB, which is actually a great service, but we chose not to use it. We don't use ELB because it means that we would be locked into hosting providers that provide identical or similar services to ELB. So since we just have Nginx, you can stand up the stack on Rackspace, for example. And one of the things we need to do going forward is actually stand that up and figure out some of these harder problems. So if you're experienced with this, we could definitely use help. Also, part of this is moving gems to a CDN. And Fastly's been really generous with lots of different open source projects. And I'm also involved in Bundler. And we're going to use Fastly for some Bundler stuff as well. And so moving to a CDN would also help with availability. And Andre Arco, who's the Bundler maintainer, has some really interesting ideas about how to take what lives on Rubygems and kind of distribute it and build kind of a worldwide network of read-through caches that are backed by Fastly. So that's another thing that could be really interesting to kind of help make the service more reliable and available. Although things have been pretty good recently, and we're now doing infrastructure upgrades pretty regularly, so we're kind of rotating hardware that the actual service lives on, because since AWS instances die in weird ways, it's better to just live on them for a shorter period of time and kind of do the Brownian motion thing where you're just constantly moving infrastructure between different instances. And that's something that I think we can push harder on. And there's a lot of automation stuff there. So yesterday I spent some time standing up Jenkins, and hopefully we'll be able to have like launching and testing via Jenkins. So we can say, give me a new app machine and return to me the public DNS, and then we can point the VIP at that instance. This is a huge thing, and this actually would have made the incident that happened a lot easier to recover from, which is signing gems. And there are a lot of different approaches. There are a few different people working on this. Raggy's working on this, and I think Google gave him some time. And there are lots of other people who are interested in it. And gem signing is a big deal, and the Python community, so Donald Stuffed in the Python community has been working on this on that side. And this is not a solved problem for either of us, and it's a really interesting, hard problem that involves distributed systems and security work and lots of other stuff. And there are lots of decisions that need to be made, and it would be awesome if we could work with them, I think, because they have identical problems with signing eggs. And the real kind of debate here is whether we want to use a decentralized system or a centralized system. So a lot of people have been pursuing X509-based signing, which means that we run a CA and we sign gems in a centralized place, which actually is hard to verify at kind of massive scale because if the CA runs on app machines, then if an app machine gets hacked, how do we know the CA is valid? Versus GPG-based signing, which I think has some really, really interesting possibilities. So one of the possibilities there is you could have companies signing gems. So you could say, I trust every gem that's signed by both Red Hat, Red Hat 37 Signals and GitHub. If all three of them have signed it, I trust it. And then companies can go around and sign gems and say, this is something that we're gonna participate in if there's an incident or there's a CVE against it, which is just a security ID basically that's tracked kind of globally. If there's an incident, we can actually take action and we'll help the gem maintainer or we'll actively write a patch. And so I think I kind of lean towards the GPG-based system, but it's fairly complicated because not a lot of people know how to do this effectively. And so there are some really interesting possibilities though. So this is a great thing to get involved with, especially if you don't hate Python, which they're really, really helpful and really, really organized and pretty nice, I think. So it would be really cool to get involved with them as well and kind of help them, ease along the process on that side, and you'll be a hero to the dynamic language world if you help fix this problem. So one of the other things is Rubygems kind of historically on Gemcoder, you used to have to request that your gem would live there, and now anyone can upload anything. So we've kind of gone really far in the other direction, and there are a lot of gems that do nefarious things. And one of the things that we kind of need to look at long term is what lives on Rubygems, what are we hosting? There are gems that are shipping binaries whose sources don't live in the gem that they've pushed, which makes security work really hard because you don't know where this thing came from. There's static analysis stuff, so if any of you program C, you know that, and other languages as well, there's some companies doing some really interesting dynamic language work in this space as well. But we don't really know what lives in gems, and it would be good to know, and I'm working on this because I think it's a really interesting project, and would love help with it because there are 60-something thousand gems. But basically, I want to find out what lives in our gems, where they're what's wrong with them, what kind of common defects are. And on the C side, we can look at static analysis. The problem is, this is really, really kind of expensive to do because you need to look at, for example, like assembly that lives in a gem. So like, who wants to write some S390 assembly? No one. And so... So there are lots of kind of diverse types of machines that we need to look at. And one of the things that I've been working on, there's a repo for it, but there isn't very much code there yet, is on push-based management. So like every time you push a gem, it gets put into a queue. We analyze it. If there are any new defects, obviously we can't like tell every gem maintainer that they then have to change their gems before we'll host it again. But if there are new defects, we'll block it and you upload again, and then we can kind of build a process that way. It's in the really, really early stages, but we already have a hook system for Rubygems, so there's no reason we kind of can't start working on this. And as I said, this is a really, really interesting problem. Python community also has this problem, and lots of other communities do too. And so I think building a generic solution and then making it Rubygems specific could be really beneficial to lots of people beyond us. And one of the things that we need, which is a human capital issue, is a way that we can prevent people from putting stuff on Hacker News, which means setting up a secure disclosure system. So lots of companies, have this, like Heroku, for example. There's an email address that you can email, and they'll send you back a GPG-signed email, and then you send them the issue encrypted, and so the entire exchange is encrypted. And lots of companies, Heroku, I believe, to be among them, have policies that say, we'll email you back within 48 hours, and if we don't, I don't know if this is part of their policy, but it's fairly standard. If we don't email you back, then you're a security researcher. It means we don't think the vulnerability is useful or something else went wrong. And security researchers are the type who like to share a lot. And so we need known short response periods. So stuff like, we will respond to you within 48 hours and we'll ask for what the issue is. Or, we'll validate the issue within 7 days. And I think that actually will take a lot of the security people. We're a huge community, and so a big part of this is being able to respond to people quickly. And like people who find issues want to disclose them. It's cool in the security community to disclose your issues or disclose vulnerabilities that you find. And so having, we'll say to them within 48 hours, we'll have a patch ready in 5 days. We will figure out whether this is a real issue and respond to you within 7 days. Stuff like that is all really powerful for getting security researchers to play along with us. And so actually having a human on the other end of this who's saying, we really will fix this, or this isn't an issue, feel free to disclose it, it doesn't affect us, is a big deal for them. And I think will definitely help kind of with both image and the way that real issues kind of get responded to. Taking this even one step further, I think, is just the fact that a lot of gems have issues, and the gem maintainers often don't understand the issues that get reported to them. And that's a huge problem, because how can you fix it if you don't actually understand what's going on? And so I think it would be cool, and this is total hand-waving, but I think it would be cool to actually set up a team of people who will help maintainers get CVIDs, who understand kind of trending security issues, and can help gem maintainers build more secure gems that we can host on Rubygems. So that's about all I have. We've got some time for questions, but this is kind of where a lot of the work is happening. These are IRC channels, so pound Rubygems AWS, and pound Rubygems Trust. The people in Trust are working on signing. AWS is kind of quiet, except it gets GitHub notifications for infrastructure stuff. And pound Rubygems is where most of the action happens. And that's the repo where the chef config lives, so if you have any improvements there, definitely send pull requests. That's all I've got.